Good afternoon, everybody, and welcome back to CCIE Labs Uncensored with myself, James Haddix. Today, we're going to be going over spanning tree enhancements. I know we've had a lot of videos on spanning tree. This is typically one of the more dull topics when you're doing your CCIE studies, but nevertheless, it is very important to understand because without layer 2, layer 3 wouldn't work. Or I'm sorry, excuse me. Without layer 2, layer 3 wouldn't work. I think I said that right, correct? Okay. It's been a long day, pardon that. So today we're going to go over the enhancements that Cisco has designed for general IEEE spanning tree. For most of your Cisco shops, the Cisco production engineers, everyone that works in a Cisco only shop, you typically don't have to worry about configuring these kind of things. Maybe except in one instance, and we'll go over that. So there are 3 enhancements that Cisco has designed for spanning tree. The command line for these enhancements is pretty simple, but the design and the application of these enhancements are very important because you have to keep in mind the design and the topology of your network. So the first one, which is probably the easiest one for everybody to remember, is Portfast. So Portfast essentially allows a port to skip 2 phases of the process when it turns on, and that is the learning and listening. Instead, it goes directly to forwarding. So Portfast kind of just assumes that, you know what, I'm not going to need all this information about PBDUs, or I don't expect anything on that, so I'm just going to go straight into forwarding. So I'm going to bring up our canvas here, and I'm going to show you the instances of how Portfast would work. So let's say, for example, that we've got switch 1, switch 2, and switch 3. And actually, instead, I'm just going to put here, I'm going to put D for distribution, A for access, and A for access. So we're just kind of referencing the campus model, or the campus LAN model. So your access switches are going to be your switches that connect directly to your clients. So I'm going to create some triangles here to represent, let's just say, VoIP, or we'll just say PCs for right now. And I'll explain why I took my VoIP reference back in a second. So let's just say that these are all PCs. So all of them have single connections to our access switches. Now, whenever a PBDU comes across the wire, the switch has to process that, so it has to go through the 5 different states, from discarding, or I'm sorry, that's in other versions, but it has to go to simply in listening to learning, to forwarding, to the other states that are involved with spanning tree. However, if your port is connected to just one singular host, then really you can skip a couple of those processes because you know that these PCs aren't going to be sending protocol. They're not going to be sending bridge protocol updates. They're PCs. They shouldn't be. So with that case, we can enable Portfast on these ports. So we can enable Portfast on these ports. Just like so. So even on the red one. So so these ports we can actually configure as Portfast. So let's just go to the CLI for a second. Let's just say switch 1. It doesn't really matter. Let's do enable. Let's just show INT status. So we've noticed we've got numerous links up, but the way that our topology is set up is that these 6 are actually connected to the other 3 switches, switch 2, switch 3, and switch 4. So let's just say, for example, that gig 0/0 is not connected to a switch, and we want to make it a Portfast. So we'll go to the interface line, and we simply just do spanning tree Portfast. Now you'll notice here that you'll get a warning saying that it should only be enabled on ports that are connected to a single host. So connecting to hubs, to concentrators, to other switches or bridges, it should not be enabled because it could cause a loop. Because it skips a few steps in the chain for a spanning tree, that it could just ignore some of the information and could create some traffic headaches. So that's why it's just saying, hey, spanning tree Portfast. Only do it on things that are connected to one host. Like here. So that's important. And give me 1 second, taking a drink. So let's just say that, for example, this computer right here, let's say that all of these are on, let's say, VLAN 100. So, and we want to create it as an access port, so we would do, you should remember this, is switch port mode access, and then switch port access VLAN 100. So, didn't create... So, I didn't have the, actually, I take that back. Hold on 1 second. If you see here, G-00/00 is actually connected to another switch. It is actually connected to switch 3. So, when I create a VLAN, I notice that it's actually on the trunk. Again, this is part of the hold uncensored thing. So, I'm actually going to go over to switch 3 and actually just shut that interface down, because we really don't need it on the other end. So we shouldn't be getting that message anymore. But again, we're just kind of showing you what the command line would actually do. So let's just say that, that's, PCs on VLAN 100. Now let's come over here. Let's just say that this switch, and I'll pick a different color this time. I'll pick a nice light blue. Let's say that this switch is in your general office. So this is in your cubicle farm. We'll label it cubicle farm. Cube farm. Now, let's say that you have another access switch that might be in your, and I'll give this another color, something a little bit easier. Let's do purple. Let's call this your test. Well, let's call this a test farm. Now, I'll say test, or actually I'll be a little bit better about that. Let me say this is your engineering farm. So, and what I mean by engineering, I'm talking about, IT, network engineers, server engineers specifically. And the reason why I bring up server engineers is, let's say, for example, that we have a server right here. We have a server. And this server runs VMware. I'm sorry, that is so loud. So let's say this server is running VMware. Now, typically on this physical server with VMware, we could have a whole bunch of different virtual servers. I'm just going to draw little dots here, or little boxes. All these different servers, or virtual servers, could be associated with different VLANs. And that means that we would have to transmit traffic over multiple VLANs. Well, the only kind of traffic you could do that over is a trunk. So there are instances where you need to configure Portfast on a trunk. And this is one of the specific instances when you have to, is when you've got to configure, is when you've got multiple traffic going over VLAN. Now, I said earlier that, you might have to, that these might have been voice over IP switches, or voice over IP phones. And the reason why I backed off of that is because you might have learned in your other Cisco worlds that your Cisco IP phones actually has an embedded switch inside of it that actually does VLAN, that actually creates its own trunk between itself and the computer, because the phone traffic is on one VLAN, which we call it the voice VLAN. So this is a little bit extra, so you guys get a little bit of extra stuff today. There's the voice VLAN, and then there is the data VLAN. So in order for both of these VLANs to be able to go across, a trunk has to be created. So, but again, that's for like Cisco specific software or Cisco specific equipment. So you don't really have to worry about that when dealing with general spanning tree. But I just want to demonstrate to you that you can, or sometimes you have to, enable Portfast on a trunk. And how you specifically do that? Well, let's go ahead and get rid of this. Let's not make this a access switch or access port. So if we wanted to make it a trunk, we would do switch port. Let's say we'll do switch incap .1q. Oops. Trunk incap .1q. Then we would do switch port mode trunk. And then we would actually do switch port or spanning tree Portfast trunk. A spanning trunk. Oops. I'm sure y'all are reading that and laughing too. So again, you get the same kind of message. So, but you notice here that you don't get to this other part saying that Portfast has been configured but will only be having effect when the interface is in a non-trunking mode. So since it's already in trunk mode and we've set Portfast to trunk mode, we don't get that message. But again, that's a particular reason why you might actually have to configure Portfast on a trunk, is because you're connected to a hypervisor that is transmitting traffic over multiple VLANs. So that's really important to remember. It's a little bit of gotcha sometimes. So that is Portfast in general. Now let's say, for example, let's go back to our switch here. Now we noticed that on switch A that we should have on a whole different range of ports that all of them are just simply access, or all of them are simply connected to computers, and we can just set Portfast, but we don't want to do it for the entire port, for all the ports. So what you can do is you can go to the global config, you can do a spanning tree Portfast default. And then of course you're going to, that is actually going to go across on all the ports. But again, Cisco's going to warn you this could create loops. So you want to use this with caution. And again, I also want to remember that this does not apply to rapid spanning tree. This does not apply to multiple spanning tree. This is just plain old IEEE STP. So that is how Portfast works. The second enhancement that spanning tree came up with, or Cisco came up with, is something that's called Uplinkfast. And this sometimes gets confused with the third enhancement that we're going to discuss, which is BackboneFast. So let's talk about Uplinkfast for a second. Let's go ahead and do a new, server topology. So let's just say that we have access switches down here. And let's say that we have distribution switches up here. So in a typical production, perfect world environment, on your access switches, you would want to have a port channel going from not only one switch, but to the second switch here. And the same this way. So I am kind of showing you what the perfect world should be like. So these should actually be all configured as ether channel, and this would, from a topology standpoint, really kind of defeat the purpose of having Uplinkfast. But let's just kind of go back for a second here, and let's just say that we're not in a perfect world, and we're not able to do port channeling. We can only have single uplinks. So we have an uplink to one switch, an uplink to another switch, and we'll kind of do the same thing here. So this topology should look a little bit familiar. Now, let's say, for example, that, ooh, this switch isn't connected yet. Now it is. So we'll go ahead and label these switches 1, 2, 3, 4. So we'll say that switch 1 here is our root. So let's go and put that in there, root. So that means that these ports here will be our root ports. And let's say, for example, that these are in blocking. So we'll just go ahead and put a red X over this right now. Actually, no, because that's going to defeat what I'm about to do next. So we'll just put a green wall right here. We'll just call these, these are blocking. So now, what Uplinkfast is configured for is, first, you should typically only do this on your wiring closet switches or your IDFs, not on your distribution, not on your core switches. So what will happen is, say for example, that we lose our link here on route 1. So let's just say, for example, and that's again why I'm taking out the red X. So let's go back. Let's say that this switch or this port goes down, but we have Uplinkfast enabled. So what would end up happening is that because this is our secondary this notices that this is a secondary uplink, and we would configure it on this port, that it will actually skip a few of the steps, knowing that this has the best path to the route. And actually, I need to draw a second. I need to draw a different. I need to draw a different line here. So give me 1 second. So. But essentially what would this do is that this would cut down on the time that it would take for switch 3 to understand how to best get to switch 1.